Hey, my name is Jamari, and the protein that I was assigned is the melanocortin 1 receptor, also known as the MC1R. This is my model. The normal function of this protein is to regulate the pigmentation in skin, hair, and eyes. It protects the human skin from damage from the sun, from UV rays, basically. I would categorize this type of function that the protein holds as a receptor. It is a receptor because it's a G-coupled protein receptor. It binds to ligands where it then triggers intercellular processes which regulate other important processes such as melanin production. Melanin is what protects your skin from the sun. Melanin is a natural substance that determines the color of your hair, skin, and eyes. While melanin and pigmentation sound the same, they actually not, but they are related. Pigmentation is the overall color of your skin, basically, and melanin is the pigment that gives the color, that gives the skin color. My bad. MC1R is found in the plasma membrane of only animal cells, no plant cells, and the type of cells that contain this protein are called melanocytes. Melanocytes are basically just a type of cell that produce melanin. To categorize the type of change the mutation has on a protein function, I would say it makes it less active because the original amino acid is argine, which has a positive charge, whereas when it mutates to cytosine, it has a neutral charge, which makes it less active. Now the structure of the original amino acid, as I just said, argine, the main functional groups that are in that are carboxyl, amine, and hydroxyl groups. The amino acid is hydrophilic and is positively charged. In comparison to other amino acids, the argine is large. The original amino acid can participate in many things such as ionic and polar interactions and also hydrogen bonding. With it being positively charged, it can contribute to protein stability, and also arginine has a special side chain called guanidinium, which has hydrogen atoms that combine with other molecules. Now the mutated side, which I marked by this blue cap, after that is the mutation. After the mutation, it becomes cytosine, which the main functional groups in that are carboxyl and hydroxyl. This mutation is hydrophilic also, but it isn't positively charged no more. It's now neutrally charged, and I'll talk about a little bit more what that does in a minute. In comparison to other amino acids, it is bigger than really small amino acids like glycine, but it's smaller than the bigger one as the previous amino acid, argine. So it's kind of between that range in a way. So yeah, as I previously stated, the cytosine has a neutral charge, which affects the interactions that it has on that. No, that just affects the interactions that it has. The two main ones are hydrogen bonding and ionic bonds. Since the new mutated acid has a neutral charge, it can still form hydrogen bonds, but the hydrogen bonds that it form are weaker than the bonds that argine can form. And ionic bonds, since it has a neutral charge, it can't form ionic bonds at all. The mutated amino acid also affects the protein mainly due to the loss of charge. I said a lot. It's kind of like the common thing here because that's the main change. That charge just overall makes the protein less active because it isn't able to bond with as many things and form good, strong bonds with as many things because it has a neutral charge. That's it for talking about the protein. Now limitations of my model, I would say, since this is to scale with a human eye, this all stuff isn't this size, obviously. The real life stuff is microscopic, so you can't see it at all. Another thing is this is like a really simplified model of the whole thing, so it doesn't really show everything, like the different bonds, and it's just like a very simple version of the protein. And lastly, it's just kind of like a discredit to myself a little bit. This doesn't look the best. It's kind of falling apart too, because it's just actually quite hard to try to get on this thing. But yeah, that's it. Thank you.